Hey guys, James Barrow here with Thoughts Matter. I've got my cup of tea. I am all ready to have a fun discussion. Today, it's going to be a direct message from me to you. We're going to talk about why we believe what we believe. We have two different ways of understanding the world. One way is through our conclusions. These are things that we determine logically. The other way is through our assumptions. These are things that we just take on faith. We don't have any logical reason for believing them. So these two types of beliefs cover all the beliefs that we have. Okay, so we're told that assumptions are bad, right? You know, if you assume, you make an ass of you and me. Okay, that's true to some extent. Here's the deal. Our conclusions have a place at one level. And I said that they flow logically, right? So if you trace a conclusion, you should be able to trace it back using like if-then statements, right? So, you know, if this, then this, if this, then this, if this, then this, and you get at your conclusion. So in order to go backwards, you say, here's my conclusion. Why? Why do I conclude this? And you jump back to your previous, what would have been your if-then statement to get here, and your if-then statement to get here. You ask why to go from here to here. And you say, why again? So I take this conclusion, and you say, why this? And eventually, you're not gonna have an answer for why. And that's where your assumptions should be. So if you're assuming things at this level, right on par with your conclusions, that's an issue. That's when you're making an ass of you and me. But if your assumptions are down here and they are the basis of your conclusions, that's where they belong. That's the appropriate place for assumptions to be. Okay, quick name change here. We're going to start calling our assumptions postulates. That's the geometry term for things that are self-evident. They're things that we take on faith. Okay, postulates goes all the way back to the Greeks when you have Euclid, father of geometry. And you might ask what his big contributions were, and it's not what you would think. He wasn't the one who came up with all the different geometry theorems that we use today. He simply took all these geometry theorems that were already proved. Well, I'm sorry, they weren't proved. They were already figured out. They had already been observed. He took them, and he was the one who proved them. He said, we've seen this to be true. Here's why we can prove that it is true. But guess what? Even he had to make some assumptions in order to do that. And they're called Euclid's postulates or Euclid's axioms. Axioms, postulates are basically interchangeable. Okay? So from the original 5 to 10 postulates that he had, we were able to get all the different geometry theorems that we have today. And Euclid played a very key role in determining that process of, okay, we make a few assumptions, and we base all of our conclusions on those assumptions. And he called them postulates, so we're going to call them postulates too. So we got two levels, right? The postulate level and the conclusion level. And you probably see me doing this with my hands. Let me explain what I'm doing. So the conclusion, I'm thinking of this as like a road, okay? So if you've got all your conclusions are different destinations on that road, and those destinations follow these roads that lead back to a few basic assumptions, okay? Kind of at the center of this at the hubs, right? Those are where all the roads kind of lead to, right? They don't all lead to the same one. They maybe have 3 or 4 or 5 or up to maybe 10 different assumptions at the center, and then all those conclusions flow from those. That's the diagram I'm kind of picturing in my head. And so we have two levels. We have the assumption level, we have the postulate level, and we have the conclusion level, okay? And the conclusion level is what I would refer to as like surface level. So when I say you need to go a level deeper in your thinking, that'd mean ask why, get to a deeper level. And eventually, the deepest level is the postulate level. Okay, so that just gives you a bit of an idea of kind of how I'm thinking about how we think rationally, how we think logically, what our process is. So again, to wrap up this segment, there are two kinds of beliefs: our conclusions and our postulates. and it should be that our conclusions flow logically from our postulates. So why does this matter? Why does it matter that we have conclusions that flow from our postulates? The reason why this is a very important structure in our thinking, this is a very intentional and strategical and practical way of organizing your thoughts, is that it centralizes where we might be wrong. Think about geometry again. As long as those 10, we'll just say there's 10 geometry postulates. As long as those 10 geometry postulates are correct, then all the different theorems that we show have to be correct, as long as the if-then statements are done correctly. As long as the logic is sound, right? As long as there's not an illogical or a fallacy that's being used in the chain, then the only point where we can be going wrong is the assumptions. So if the assumptions are true, the conclusions must also be true. It centralizes where we might be making a mistake. It centralizes where that error might be, and it allows us to pinpoint where we should focus on in our thinking. Okay, we know that this conclusion is right as long as this assumption is right, so we should then target the assumption to make sure that that's right. So it's very practical and strategical. And it works for other people too. If we can figure out what their assumptions are, then we can target those and say, I think this assumption is wrong. This is why I think you should adopt my way of thinking. Okay, so it helps in discussions, and it makes discussions that would otherwise be very impractical, very they wouldn't get you anywhere. You know, how many of you have just talked with a friend about politics or something, and you both come away thinking we didn't get anywhere. In fact, our relationship is worse now. That's because you probably were staying at the conclusion level. But if you get down to the assumption level, you can actually make a difference, because that's where you're going to potentially change someone's mind. Because if you're trying to target their conclusions, as long as their assumptions stay the same, they're never going to adopt your conclusions if they're starting from radically different assumptions. So we've talked about two kinds of beliefs. We've talked about why it matters. I want to talk about two different types of reasoning as well. We have inductive reasoning and deductive reasoning. So I'll start with deductive. Deductive reasoning, we're familiar with Sherlock Holmes. He deduces things. Deductive reasoning is that logic I described earlier, that if-then logic. If this, then this. Deductive reasoning is something that is a way to prove things. You can actually prove things deductively. Inductive reasoning is additive. In other words, it relies on volume. It relies on a volume of evidence. So you can't ever prove something inductively, but you can overwhelm someone with evidence to say, this must be right. I can't prove it logically, but I provide so much evidence that I can't see how this could possibly be wrong. Think back to geometry. One of the postulates is that all right angles are congruent. Okay, we've never seen a right angle that wasn't congruent. Therefore, we think that this is pretty, it's a valid assumption. But if it would only take one right angle to be not congruent with all the rest and still be a right angle, that would all of a sudden shake our belief in that postulate. And then it would cause all of our other theorems based on that postulate to come into question. So your belief in God, or your belief that there is no God, you have a lot of evidence to support that. You know, if that's what you believe, you've got your group, your collection of evidence, and you add on to that, and you keep collecting more evidence, and that's the only way that you can convince someone else that there is a God or there is no God, because you can't logically prove that one way or the other. So you have to rely on this additive form of reasoning, this inductive reasoning. So that's important to know the distinction between deductive reasoning and inductive reasoning. Do I think that people really follow this chain of thinking? You know, this assumption, all of our conclusions flow from that. Do I think that that's actually how our minds work? I don't know. I go back and forth. I think it is. I think that it's an assumption that I am making because it's a useful assumption, whether or not it's true. And there is evidence to say that people aren't necessarily rational. I think that people whether they know it or not, they do have a few things that they believe that their conclusions flow from. And I say this because in my personal experience, I was able to identify what those few beliefs are. And so I think that it's true. There is plenty of evidence to say that people aren't necessarily rational. I think of Danny Kahneman and Amos Tversky. These are two Israeli psychologists that dedicated their life's work to showing that people are not always rational. But even in their experiments, they found that when people were presented with the rational thing that they should have missed or they should have caught, they may have made an error when presented with this problem, but when they were shown the solution, they were like, oh yeah, I can't believe I made the mistake. That kind of tells me that people might not be rational always. They might not always act rationally, but they can at least identify what rationality is and what logical thinking should be, which I think is evidence of this, that this conclusion, postulate, model works. When I was young, I was afraid of conflict. I was worried that someone else debating with me about something that I believed very strongly in, that I would hear some arguments from them that I'd never thought about and that were very convincing, and that I might be convinced. And so when I found myself in those situations as a kid, I would think, okay, this person tells me this, that I know I don't believe or I don't agree with them, but I don't know why I don't agree with them. So now I've got to go read a bunch of stuff that confirms my beliefs. And this is how most of us go through life. We know that we have these vague beliefs about life, but even when we hear very convincing arguments on why they're not true, we think, well, I still believe them, and I've still heard some equally convincing arguments for why they are true, so I'm going to go and read those and then and believe those because that's what I believe, right? Why do we do this? As a kid, I could recognize that this wasn't intellectually honest, and so it was something that scared me. Conflict like that concerned me. I didn't know how to get out of that cycle of the person who reads the most and knows the most facts about their argument, they win the argument. In other words, truth is determined by how much you know about your argument. Well, that's not true. Truth is not determined by how well or how good of a debater you are or how much you've read. Truth is truth, and people should be able to have discussions regardless of how much they've read. If they've been thinking about some of these issues, they can still help bring people along in a journey to discover what truth is without having read more than the other person, without knowing more facts and more anecdotes, more statistics. These are things that aren't what determine truth and are often not helpful in getting at truth. So to end this personal story, I realized that the reason I wasn't convinced by someone else's better arguments or arguments that I'd never heard before was because they conflicted with my postulates. And that realization has made all the difference, recognizing that the reason these people have these arguments that sound convincing at a conclusion level, and I might not be able to argue at a conclusion level, but I can still disagree with them and be totally justified in disagreeing with them because I recognize that their assumptions, that their postulates are different. And if they have a different set of postulates, they will naturally arrive at a different set of conclusions. That realization was very comforting because I'm no longer afraid of conflict. If I disagree with someone, I'm very interested in knowing what their assumptions are, because then I can say, oh, we have totally different assumptions, so it makes sense that we disagree. If we have the same assumptions, the same postulates, and we still disagree, that concerns me. Then either I've made a logical mistake or they have. And we can both grow from going through that process and figuring out which one of us has made a logical error. So all in all, this type of this way of recognizing, this way of thinking about human rationality really does make a difference in how we go about discussions, and it makes a difference in how we approach conversations. We're no longer ruled by how much we've read. We're no longer controlled by the anecdotes and the statistics that we have to back up our beliefs. We don't have to rely on those anymore. So where do these come into play in a form of discourse that I'm describing in this video? I'm talking about getting back to your postulates. Well, it seems like you don't need anecdotes or statistics in that form of discussion. So should you just no longer use them at all? Not quite. So you shouldn't use them at first, but they come in handy later. So at first, when you're going from conclusions to postulates, yeah, don't use them. Put them aside. Put aside your anecdotes and your statistics until you and the person that you're talking with, both know where your assumptions lie, where your postulates are. Once you've identified your postulates, then bring those anecdotes and those stats back on the table, because those are your inductive arguments. Those are the things that you use to make someone lose faith in one idea and adopt faith in another. That's the only thing that can happen at the postulate level, right? You can't use logic. You have to use inductive reasoning. No deductions, only inductions. So I've made it through my cup of tea, so I know it's about time to end this video. The ultimate goal here was to, yes, explain to you my theory on human rationality, to explain to you, this whole idea of conclusions versus postulates, of deductive versus inductive reasoning. But the ultimate goal is to get to this point where I can give you what I'm calling the postulate challenge. The postulate challenge is a challenge from me to you to identify what your postulates are, what your assumptions are, that all of your conclusions flow from. I'm thinking between 2 and 10. I think we all have a collection of postulates that we base everything else on. I really want to know what yours are, and I think you need to know what yours are. So the challenge here is to take half an hour, write down some of your conclusions, and ask why. Write down, a conclusion about something political, maybe about immigration, something about the death penalty, something about abortion, whatever. And then ask why. Why do I believe this? And then ask why again. And then ask why again until you can't answer why. And when you can't answer why, you've probably reached a postulate. And then maybe start to think about some of the inductive reasoning for why you take that postulate on faith, why you believe in that postulate. Let me give you a silly example. One of your conclusions might be, and this is not a philosophical conclusion, but this is just something that we observe. When you drop a ball, it will reach the ground in a certain amount of time, right? Based on the speed that balls fall to the earth, based on gravity. How do you know that ball will fall at that speed and will hit the earth? How do you know that it'll fall at all? So that's the conclusion. You ask why. Why do you think it'll fall at that speed and hit the ground? And for most of us, the answer would be, well, physics. The laws of physics kind of dictate that that's what's going to happen. Okay, so we've gone one step back. Conclusion, ball. Second conclusion is physics. So why physics? Why do those laws of physics affect balls? Why are particles affected in the way that they're affected? A lot of people couldn't answer that question because we observe Newtonian physics to affect balls, and so that's pretty much it. We can only say that every time we observe a ball dropping or an apple falling from a tree, that's what happens. Okay, so that's now where we've reached the postulate, and the inductive reasoning now comes into play. Well, every time it happens this way. Okay. Some people could take it a step farther, though. They could say, well, I believe that God put the laws of physics into place. So, ball drops. Why does ball drop? Gravity, physics, science. Why science? God put those laws of physics and science in place. Okay, so that would be where the postulate is. It's God. So you kind of start to get a feel for how you work from one conclusion back to your postulates. Some chains will be a lot longer, some chains will be very short. But everything, you can just ask why and just follow it back. So again, between 2 and 10 postulates, see if you can figure out what yours are.